we discussed yesterday two cases, one 15 holes on one plate and second 15 plates with one hole, and we said we have 15 different process instances of the same type for the same process. This example here shows a little bit more complex because on each part there are two different parts and we have two different features. I call them features, so the one is hole, another is a slot. So we have two products, P1, P2, two slots, S1, S2, two holes, H1, H2. On P1, we do them on two different machines, machine 1 and machine 2. On case 2, we do them on the same machine, machine 1 in both cases. So my argument that we have...
They're both on the same day, the same work item?
These are two different work items?
Yes.
Because you see the difference?
No, and on the right-hand side, you do them on the same machine, on the same day, with the same work item.
Yes.
Yeah.
But on the left side, I do the same thing on the same work item on different machines.
Yes.
So my argument...
Well, no, because it's a different work item. One is a slot, one is a hole.
Okay.
Yeah.
There are three things. There is a part that we want to make, which is this here, that contains two things, hole and slot. In general, we always have that requirement. In general, we can do them on one machine, as in the right case, or we can do on different machines. My argument was, and this is what common terminology in manufacturing, that this on the right side we do have one operation, on the left side we have two operations, because machine defines operation. This is one of the definitions. I'm not saying that's only definition. And that's that the example shows here. We had yesterday 15 operations against one operation. Here we are showing even if I have one part, one plate, I can have two operations.
Yeah. I would say that we were assuming yesterday that we would have a universal definition of what an operation is, or a universally applicable set of conditions on what makes an operation. Okay. I think that that's wrong. I think that the word operation is going to be flexible. And what counts in one factory as one operation may count in another factory as two operations. In other words, the ontology is not going to give us a definition of what an operation is in the granular terms that you were presupposing. Rather, let's go back to the simple case, the 15 holes. So, in a given factory, 15 holes in one plate is counted as one operation. 15 holes in 15 separate plates is counted as 15 separate operations. But that means that we can deal with the data about the work processes in that factory using drilling, active milling, and the term operation. But then we have to define operation for that factory, because in another factory, it may be that they count manufacturing processes under the heading of operations in a different way. In other words, we can't embed into the ontology any specific requirement about what counts as an operation. And if you try to do that, you are weakening the flexibility of the basic ontology approach.
Yeah, but you are not providing guidelines how to use ontology.
We are providing guidelines for using ontologies when it comes to simple processes like active milling, active drilling. We're providing guidelines for use of ontologies for dealing with things like parts, features, machines, and also work orders and so forth. And then we're providing a guideline for understanding complex manufacturing processes by using the term operation. But we're not providing a universally applicable definition of operation at the granular level that you were proposing yesterday. I just don't think that will work. Operation has to be a somewhat flexible way of grouping different kinds of...
in some literature, you're going to see that this act of drilling they call operation, manufacturing operation.
That would be fine. That would be fine. Then there would be 15 operations in both of the two simple cases in that factory, or for when people are working.
Okay, so
operation is just a superclass for active milling, active drilling, and so forth.
Yeah, but other operation is not superclass. Other operation is, I mean, that's whole argument that I'm trying to say is collection of 15 hole drilling processes. That's operation. It's not only each of them.
Yeah, and in another factory where they use the term operation in that way, it would indeed be one operation.
I mean, that's fundamental. I thought that we are going to give them. Question is why not? You're trying to say that there is no difference between factory that there is no similarity in the factory that makes cars and makes airplanes or jet engines.
So
you're saying that only similarity is how do we transform, how we do milling and drilling. You're saying that anything else with respect to how it's organized is completely different.
No, there'll be many similarities. I've already listed them, but they all use machines, they all use work orders, they all use inputs and outputs of manufacturing processes, for instance. We haven't talked about any of that.
Yeah.
They all use features. Now, what I'm trying to do is to avoid a combinatorial explosion. So we certainly do not want to have in our ontology a definition of a 15 hole in a plate drilling operation, because then we'll need.
Oh, that's okay.
So what we need.
So why do we need machine?
Because that is going to be a common feature across.
Yeah, why do we need machine in these processes? Why do we need machine? Why don't we do that manually?
I don't say we need to specify the machine as part of the process. We don't. The process is just an act of milling. Now, we will define what an act of milling is. And I don't know whether an act of milling is always carried out by a milling machine or whether there are multiple kinds of machines which carry out acts of milling. We're going to be tagging not just the processes, we're going to be tagging also the machines. What are the capabilities of this machine?
I agree. I mean, you're simplifying here. That's definitely. I mean, it's machine one, machine two. Different types of machines can do different processes, and there's multiplicity. But for any of these manufacturing processes, you need resource, which is machine.
Yeah.
So you need another resource, which is tool.
Let me just
mention two different roles.
Let me mention another use for the ontology, which is something that we have explored also in the biological case with it.
Yeah.
And some of those machines are doing very, very precise things with specific kinds of genomic analysis. And so parameters and protocols and so on, which are very precisely determined. And the inputs and outputs are very precisely determined. So there are catalogs. To buy a machine, you go to the catalog and you pick what machine you want. Now, one of the goals of ontology, industrial ontology and biomedical ontology, I think, is to create online searchable catalogs. And the catalogs would all use the same ontology so that you can compare machines by exploiting the information captured using the ontology before you buy them. That would be the idea. And also, you could use this to supply chain informatics, where you want to know what the capabilities are of a given factory or a given enterprise, because you have described the machines and so forth using a common ontology.
So if you don't define that this drilling needs machines, so what are we defining when you say act of drilling? If we don't define that it requires machine, then what are we defining there?
Oh,
act of drilling requires that you have a workpiece,
yes,
plate, that you have a tool, and you have a machine. Tool gives you a geometry, machine gives you power or energy to do this drilling.
I don't see any objection to that. That's not my expertise. I am quite happy to define an act of drilling in such a way that it requires all of the things that you just
yes, that's my argument.
But now that takes us down a different avenue from the avenue that we were exploring now. I am not objecting to having precise definitions where we can craft such precise definitions in a way which everyone will accept. What I'm objecting to relates to words like operation, perhaps also feature. We need to talk about feature.
No, yeah.
Where it's apparent, or I'm tempted to believe that we're not going to find a way of defining operation in such a way that everyone will agree. And you gave an example yourself. In one textbook, operation is defined in such a way that it's just a parent class for manufacturing process in the way that they are defined already in the Common Core ontologies, where we have active milling, active drilling. So operation is just going to be more flexibly defined. It's still going to be defined. An operation always includes at least one manufacturing process. An operation is always specified in some kind of work order or specification. There we would have to work on the precise terminology. We are choosing our battles. We are not going to try and define everything. Built into the ontology, some of the things we will leave flexible.
If you leave them flexible, then you are going to have people in food industry and people in car making doing the same thing.
Why is that a problem?
Waste.
So
Inconsistency.
Give me a story which where it would cause a problem. Give me a concrete example.
I'll give you examples. So 20 years ago, 30 years ago, there were no computers in car. Now every car has a computer.
Yeah.
So you cannot say that you cannot separate automotive industry, electronics industry, because they need to have a meat in the car.
Yeah.
So if you have a automotive industry, mechanical part has built one ontology, and electronics industry build different ontology, you are going to make conflict.
Okay.
So building cars, modern cars.
So the strategy that we have involved with BFO at the top and then modules lower down is designed precisely to rule out problems of that sort.
Yeah, but if you don't define that in higher level, what I'm proposing, then you are opening space for them to be defined differently in lower level.
We do define things at a high level, and that is precisely why we need to have flexibility. So let's take operation again. Supposing, and I'm just following your example, I haven't thought it through in any detail, but supposing that we have a company which is using the IOF ontology, and it's talking in terms of operations and acts of milling, acts of drilling, and so on. And the company moves into car manufacturing. They want to continue using the same ontology, but now the manufacturing processes that they need to utilize and plan and schedule and so forth include computer processes. That's no problem, because if the word operation, and that's what we're arguing about, if the word operation is defined flexibly, as I suggested, then we can have operations which include both manufacturing processes and computational processes be part of one and the same operation. And let's suppose that we define operation more narrowly from the start. So we define operation to be a manufacturing operation. Then once we start introducing computational processes into the same factory in the same, we would have to redefine operation.
Are we talking making computers or using computers?
Well, that's a detail.
It is big important detail, because in making computers, you use everything that this is manufacturing operation, making computers. Using computers is not manufacturing operation.
So
making computers involves. You can start.
The issue now is with regard to operation. I'm suggesting that an operation can perfectly well include both operations involving using computers and operations drilling machines.
I'm okay with that, but in this example, we do have your proposition is that drilling is operation and milling is operation.
Yeah. Well, no. Yes.
My
My proposal is that we define operation in something like the following way. In the details we have to look at more closely when we have the IOF core ontology in front of us. But an operation is any collection of processes within an enterprise, which might include manufacturing processes and might involve use of computer processes, which is specified in a work order as an item, or as here we get into words like step now. But anything which is specified in a work order as a collection.
So we have to go back and define what is work order.
Yeah, of course.
I mean, we are delegating. So
all the term operation is doing is creating a unit.
is work order collection of operations?
So a work order, the difference in a work order and an operation is that the work order is on paper or on the screen,
Yeah.
where an operation is a planned process or a collection of planned processes.
But does one work order corresponds to one operation?
I don't know. I would say that a work order typically will involve multiple operations.
Or is work order focused on one machine or one product or one operator?
And I think it would be different in different factories.
No, it's the same factory could be the same. You need to have all three of them. Machine needs to know what this machine needs to do. You need to know what everything you need to do in one product to make it, and then every operator needs to know what is he or she is going to do to that.
Okay, so
there are three different work orders.
Okay. So in other words, you have a work order for the machine, a work order for the person, and a work order for
product.
So, and how are work orders divided? By day, by hour, so what is the flexibly?
I think in modern manufacturing is day. In some old manufacturing could be week, but day. But then you can break them down to hours. If you have a list of what I have to do today, then I can say in morning I have to do 2 things. In the afternoon I have 3 things. So if I'm going to, from operator perspective, if you're talking about work order for product, means everything that you have to do to finish the product. Yeah, actually, yeah.
I'm tempted to define operation in such a way that you have an input which comes from a previous operation, and then you have an output which goes to another operation. And you're calling everything a product. It comes in as a product. Yeah.
Okay, product component, depending what is your process.
Yeah.
Component if you're doing machining, product if you're doing assembly.
Okay. So let's just talk about an input and an output.
Yeah.
An operation has an input and it has an output. Anything in the work order which is specified as an input going into a collection of processes, followed by an output, would be an operation. Is that a good starting point? So if you have the input, which is the plate gets 15 holes, and then you have an output, which is the plate. If you have an input, which is the plate, it gets 1 hole, then you have an output, which is the plate with 1 hole. Is that a coherent way of defining an operation?
Yeah, this example is simple. In this case, I do have a 2 at this left part.
Yeah, I think it
has to visit 2 machines.
I think it would work.
To visit 2 machines. Is this 1 operation or 2 operations? And then on each machine, right now we do have 1 feature.
You need
and you have multiple processes.
You need to move the part from the one machine to the other machine.
Yeah.
So you have 2 operations. In the case where you could do both the drilling and the milling on one machine, you have just 1 operation. Because there's only 1 input step and 1 output step, where in the other case there are 2 input steps and 2 output steps.
So you are accepting my argument that machine defines operation? This is where if you follow industry, I think operation and most of terminology in manufacturing is biased, and I think intention for ontology is basically to remove the bias, to make it clear. So, bias is different. Company, industry, culture. I would say classify it is different. It's a company culture that business majority. It's 100 years, the same way we have to change. And if you use this in your building ontology, you are going to, that's my opinion, you're going to make mess. I am arguing for clear definitions which correspond to exactly what is happening.
I agree, but again, I'm trying to do it in such a way that we avoid combinatorial explosion.
I never mentioned combinatorial explosion.
No, but I think that your attempt to be clear is running the risk of yielding a combinatorial explosion.
I think it's miscommunication, because my argument for this 15 holes being in one operation is not how many of them are, but fact that they are being done on the same machine using same tool, same machine actually. I just go and drill all these holes and then remove everything. That is my argument. So there is no combinatorics there.
Right. Supposing that we have industrial baking, we have an enterprise in
industrial food production,
making many cakes. They use machines.
Yeah.
They have operations. But the final icing on the cake is performed by a human being without a machine. Are you going to use the word operation for this final human being hand icing process? Is the human being a machine?
A good point. Yes, I think human being provides in that case same thing that machine provides in this case, which is energy to.
Okay, so then we cannot define operation in such a way that it is restricted to inputs to machine processing.
I agree.
We can define it in such a way that it's restricted to having an input and having an output. Because even the human has an input, which is a cake, and an output,
glazed cake. Yeah.
Right, I think this is a good place to stop.